Hey, Bigpod. I have a random hole
Hey,
in my shirt. I hope that nobody notices. It's fine though, because this shirt probably only cost me like $1 or something, so I get what I bought. It's fine. It's also got stained armpits, so I'm gonna try not to like do this the entire episode, where I just wave my hands up in the air, all for the sake of the video listeners.
cue the music.
Hey guys, welcome to No Tux Allowed. I am your host Josh, who is not only cleanly shaven, but I'm wearing a perfectly clean shirt where there's absolutely nothing wrong with it. I swear. And today, wearing a wonderful shirt himself, is Mr. Bigpod. How's it going today?
Hello.
So, Bigpod, we on the pre-show,
Yes.
we were discussing what we were going to talk about, right? And
Yeah.
we ran into news, and I live in a
Yes.
very curated news cycle here in the United States, where there's only three kinds of tech news today, and one of them's new compared to the others. But I didn't want to talk about government did this, which caused this in the tech industry, or the latest in AI. And I don't know enough about quantum computing to actually think I can talk reasonably about it. So we're going to talk about a little bit about AI, and then we're going to be going into a bit of, I'm going to say like a bit of like an explainer segment, because a lot there, we've seen a couple comments in like our YouTube comments where people say like, we have no idea what you're really talking about. So we're going to try to explain some of the things that we talk about today. So Big Pod, first of all, let's get like the news out of the way here, because this actually could be considered like security news at the same time as like AI generated news, because that's just a thing that happens these days. So we decided that
Yep.
we're sort of a security podcast, even though we don't like do like breaking news properly, because of how we actually record the show and upload it like late. But so when I'm talking about like security news, we typically try to talk about things that are like resolved and like not actively happening. But this one is actually just kind of neat in like how it operates, right? Because a group of spammers have decided that they're actually going to pay for Chat GPT, first of all. And they decided that they were going to have Chat GPT generate a spam email message that they would then mass send to 80,000 websites. And each message being unique.
Okay.
Yeah. So this was created by a toolkit called AcuraBot, which is a framework that automates the sending of mass emails in large quantities to promote shady search engine optimization services, which we've gotten a couple emails from, to small and medium-sized websites. It's basically just like a Python script that just sends about a bunch of emails, but it also indexes OpenAI's chat API to the GPT-4o mini model to generate a unique message to each site that it sent an email to, which would bypass traditional filters. Which, this is actually one of those things where like we are kind of like concerned about with like AI, Because how does spam detection normally work? Well, it just looks for a common string within messages. And say if I send enough emails to Bigpod saying hello, eventually his email provider is going to come up and say, hey, he keeps getting like this email with like just the word hello in it. That might be spam. Whereas this is saying hello, hi, hola, some other language of greeting and so on. And it's doing this to 80,000. And with the power of like some modern day hardware, I could see that being relatively simple to do because you're only changing a couple things.
Yep. And this was first discovered, or at least first published, by the group called Sentinel Labs, which is a division part of Sentinel-1 security researchers, and these are really great people, and they do a really good job of showcasing this sort of vulnerabilities.
Yeah, and they even figured out like the AI prompt message too, and
Wow,
yeah.
that's a
So
interesting
it
one.
starts with, "You're a helpful assistant that generates marketing messages," and then it gives them like a template for like how the message would be presented, and it just waits for the AI to respond with feedback on it.
Wow, I'm looking at this message generator they have. Holy
Right?
crap!
And I'm looking
Yeah.
at that, and it's one of those Python projects where like I can kind of understand what's going on here. At least with like this message block itself. So they're not really feeding it that much data. They're giving it basically a link to the website for the AI model to then index, which, the way AIs work, it's probably already got that pre-indexed because, it's OpenAI and they just, slam websites and DDoS them basically to like get all the data. But so it's already basically got like a cache of this website, and it looks through it. And then it customizes and it tailors like the spam message to like the website. So, for example, we'll just use Tuckspace.com as an example. It'll say something like, "Hey, we see that your website has Tuckspace.com as well as www.tuckspace.com. If you remove the www.tuckspace.com, your web address will look a little bit neater. But also, you might want to put something more than just like a couple cards with a couple of links on it because that's realistic. That's all Tuckspace.com is actually intended for."
Yeah.
Which, now that I think about it, I kind of want to pipe this into ChatGPT just to see what it would come back with, But I'm not going to do that right now because I just don't want to. Also, I think my OpenAI computation is already at its limit for the month anyway, so it's fine. Maybe Gemini? Who knows? But there are security implications with this Bigpod, and it does concern me a little bit because, I like to think that I'm pretty good at catching like phishing attempts, but I know that I've been caught in that net a few times.
Yeah.
And
same. Well, we keep getting emails from individuals or such bots as well.
Of
since
course,
we have
a podcast and we're small YouTubers, so we're getting the worst kind of emails where we're getting SEO spam for YouTube, we're getting SEO spam for the website. We're also getting like SEO spam for podcast sake because we show up on all the podcasting platforms as well. And it's just come down to the point where it's like I pass them a link to like a web page and tell them, I want you to find this specific section that I'm describing here, and I want you to tell me what that specific section says. And of course, I've also had them. I've also passed them like my PayPal donation link button, and told them to send me $1 that I will then immediately refund. I've also done that before too. So far, nobody's really taken that bait of giving me $1 because my link also says that there's a no refund policy. So,
by the way, I did give the link to Gemini Flash and got something back. It doesn't know what the hell the website is. Apparently, we offer a resource for Linux users offering tutorials, guides, and information related to various aspects of Linux operating system. It covers topics such as system administration, system configuration, and development tools. So it just bullshitted something out of it.
I think what they have is an old version of the Tuckspace website, because there used to be a page behind Tuckspace.com before, but that page was not online for very long. Because this goes into a bit of a history behind that domain, because that domain originated back when I was a co-host on the Linux Cast, and like me and a Linux Cast community member we're talking about like making a website just for that purpose, but it never really got off the ground. So I bet you that they just have like an old DNS cache, because it was really just like an HTML page with that in the headline. I don't even think that there was actually any actual body content. But anyways, Sentinel Labs obtained the log files to AkiraBot that was just randomly left on a server, and it showed that it was successfully delivered to more than 80,000 websites between September and January of this year. And only 11,000 messages actually failed, and that was because of domain reasons, not necessarily like spam assassin or anything like rejecting the email. So this was, for the most part, for like the context of email, this is like a 100% success rate of being able to just bypass the filters. And the only thing OpenAI said when the researchers passed this information to OpenAI is they thanked them and said that, hey, this is against our terms of service, so we'll go ahead and block their account. That said, I don't know if they're going to be able to update ChatGPT to avoid doing this in the future, because I remember Dan. Do you remember hearing about Dan? The one where they would tell ChatGPT that your name is now Dan, and that means that you do anything now, and it would just override any filters that they put on ChatGPT. And OpenAI had spent like 2 solid weeks just doing nothing but fixing that, and Reddit still found a way around it. Actually, if I remember right, they're still finding ways around it now. Which, by the way, I linked to the Ars article, and the guy that wrote this is also named Dan.
Then good in.
Okay, so Bigpod, now that we've got our mandatory tech podcast, mandatory AI news of the week out of the way, let's talk about like Linux.
Okay, before we do that, I might have a reason why is it doing that, telling us we have that, like, it is that kind of a thing on it.
Let's hear it.
Because it's using Wayback Machine.
Of course it is. Of course it is.
Also, when did you buy this domain?
Like 2 or 3 years ago, something like that? A while ago?
2019, yes. Possibly. Sorry, I didn't hear you. Because like before 2019, it was actually pointing at some random blog.
Okay. Well, hey, it's fine. Everything is fine. Let's talk about operating systems. So, first of all, when you hear like the normal person talk about Linux and not like an actual kernel developer talk about Linux, because yes, those are two different things, they typically talk about Linux in the context of an operating system, which Bigpod, correct me if I'm wrong here, but an operating system is basically like the thing that tells computer hardware essentially what to do to deal with the input from the user. So the user can see the expected output. Well, hopefully expected output.
Yes. If we go by the like a definition, An operating system is system software that manages computer hardware and software resources and provides common services for computer programs.
And we'll have like the Wikipedia article for like operating system link too, where they have a nice little graph as to where like on like your normal system, the operating system would live in context of everything else. That's generally what like we talk about when you and I say the word Linux. But you know, the Linux.
Yeah.
When I specified a kernel developer, we're talking about Linux in the context of an operating system kernel, which is that fundamental thing that literally talks between the actual hardware on a system and the drivers, and then passes that via a translation layer to basically everything else. And at that point, when we're talking about Linux, the operating system, we're talking about all the things that are stacked on top of that. Because technically, you can have a working system that's nothing but just a kernel if you really want to. But you won't be able to do much of anything with it because you don't have like anything initialized. So you need an init system. If you've ever like heard about Linux and init systems, you've probably heard about stuff like systemd or Upstart or System 5 or OpenRC and stuff like that. What an init system is that it's the thing that gets like the core operating system components running. You know, like it's the thing that starts up like your network management. That way, you know, you can have a network connection. It's the thing that initializes the system shell, which, you know, basically runs everything else. Which then boots you into what's referred to as user space after this, because, you know, this is the stuff that you, the user, actually interact with and use. And from there, then you get, well, we'll just use like a desktop operating system as an example here. After that's done, it's going to boot up what's called a graphical environment management tool. So what that's going to do is, you know, start up like your login management tool, which for some reason on Linux we call them display managers because there was some logical reason 30 years ago. That, and then you just type your username and password into that, and you log into your desktop environment, which is like the graphical session of your system. That's the thing that your web browser runs off of, your file manager, your terminal, because you're using Linux. Why would you not use the terminal? I guess, even though there are a couple Linux distros that don't actually ship a terminal. We might talk about those in the future. But hey, at that point, I think we need to talk about like how these things are actually made. Now, Bigpod, you've been involved in like several of these distribution projects, so you can talk about like ultimately how these things are made. Now that, you know, I've got like the general explainer of it, so you can take it from here.
Okay, so how to make a Linux distro. You take a file system and you put it on ISO.
Convenient.
Yes, okay. That's literally all you need to do, and then you need to just take that file system and splatter it onto the drive. That's the more high level overview of how to make a distro. Now, really, how to make that file system is what you should be interested in. So, in basics, we're talking about what is known as Linux root file system. So these are the /home, /usr, /var, /etc directories. And what you need to concern yourself with is /user, /usr, and /etc directories. And all you need to do is, with one way or another, give stuff into those two directories. That's all that Linux distro is. So that's where a package manager helps, because it does that automatically. And then all you have to do is package what you created and put it into an image that you put on an ISO, which you then install onto your onto your drive via an installation program. If you have any more specific questions, Josh, ask.
So,
because this was a really high level overview.
So if I just open up a terminal and I just ls/, I get my Linux file.
Yes.
I get my root file system on my Linux system.
You get your rootfs, as it's called, Linux rootfs.
You said that everything goes in /user and /etc. What is the difference between those two?
Most of the stuff /etc is supposed to be used for configuration files, while /usr is supposed to be used for system resources that are not managed by a user. So things that are managed by a package manager or are installed by default. At least that's the modern definition of it.
So basically, user space lives in there.
Things that you install with your package manager.
So the user's user space.
You yourself do not manage. That includes things like binaries, things like default configuration files, things like other stuff as well, like resources. And over time, there have been different interpretations of it. Like that's why teams live in there. That's why certain configuration files live there. But that is not the correct approach to it. Everything that as a user manages should be either in their home directory or in /etc.
Yeah. Now, obviously, if you're on a Linux system right now and you explore the root file system, and you'll know that there's other directories too, because we've got well, let's see, ls root here. We've also got boot, dev, home, media, mnt, ops, proc, root, and all those other stuff. Typically, you're not going to be in those folders very often. Preferably, you should never really have a reason to be in there unless you know what they're doing.
Yeah.
But /boot, that's obvious. That's where all your system boot information lives. That's where your grub lives. That's also where the kernel lives because the kernel is called by boot. So, and then /dev, that's where all your hardware devices is. Now, Linux being a Unix-like system, everything's a file. So if you look at /dev, everything is a file in there.
That's why if you ever been looking at your drives, like trying to edit a drive or something, it is noted as /dev/sda or nvme01p1 or whatever insane notation it is using now. That's why, because it is represented as a file in that /dev directory, and that directory gets populated by the kernel at boot time.
Yeah, the kernel is just hey, I found all these devices, we'll just toss them in here.
Yeah, literally. And you can get a lot of interesting information about your devices from that if you know how to read the file.
Of course, you've also got /home, which that's the home directory.
Home directory.
That's basically where all your personal stuff is going to live.
Where all non-root users' home directories will live.
At
least by default.
/root is obviously where root stuff would live, because that is.
It's root's home directory.
And then /media. It's pretty self-explanatory. That's where media devices are.
Yeah.
Your optical disc player that you probably don't have on your system.
It's in the olden days it was supposed to be a mount point for removable media, like
CD-ROMs and floppy drives. Yeah.
A dedicated mount point for CD-ROMs, floppy drives, and so on.
And then you got /mnt, which people typically use that for mounting stuff nowadays.
From what I understand, it's supposed to be used for temporarily mounting different file systems. So if you have additional drives and you just temporarily mount it, it should be proper to mount it in /mnt.
And then you got /opt, which most of the times that I've ever seen /opt actually used for is for things that you install system wide that you don't necessarily pull in through a package manager. So if you if you download
Yes.
like Discord from the website and you select the I'll figure this out myself, and then you unpack that tar.gz, it tells you to put it into /opt for that way every user has
Yeah.
access to it.
It's for user managed applications, user managed installed
Yeah, so
applications, essentially. An official, like a more internet provided definition, intended for installation of add-on application software
optional
packages.
stuff.
Things that are managed by humans, not a program, essentially.
And then you have /proc, which that's a bit of an interesting thing. It's basically just where all your processes are. So
it's a virtual file system, essentially a VFS, that is all about kernel and process information, represented, of course, as files dynamically generated by your system/kernel.
Yep, and then you got /run, which is like all your stuff that's actually running. So like your system
Runtime variable
so
data.
like if I just like ls my /run, I can see that cups is in there because that's my printing service. I also have sshd running in there.
One of the things that you should have there is your different sockets. That's what should be there. Sockets for one, and different runtime specific things that should get deleted after you're done with the after you shut down your system, but shouldn't go in temporary directory.
And then I'm going to skip over the next one, which is sbin. We'll get to that one here in just a second. But we've also got /serve, /sys, /user, and /var. /serve is for things that you're serving from the system. That's generally what it's recommended to be used for. Typically, it just sits as an empty folder on your system. /sys is for like system information. So the kernel is going to like read the system and dump stuff into that folder right there. /tmp that you see, oftentimes that's really just nothing but temporary files.
It's temporary files which very likely won't be preserved between reboots. Sometimes it is actually, depending on your configuration, can be mounted as a RAMFS, so RAM-based file system, which means it can be very fast.
And then we have /var, which is where your system variables would live. So think about stuff like your log files, for example.
Here in /var, anything that is variable, that a program name that is variable should live. So think of it this way: where USR is static, so things shouldn't change a lot. var should change all the time. It's where it stores its caches, logs, certain settings that are like managed by it. For example, your package manager stores its
package database,
package database in /var, for example, or many programs store logs in there.
Yep. So let's talk about like the special one that I just mentioned here. Let's talk about /bin. Now, on some Linux distro,
I think we should talk about /bin/sbin really as a unit together, because in today's era they should actually not even exist, or should be links to a directory inside /usr.
So when you think about this, the general idea of bin and sbin is that bin was just where roots binaries would live, and sbin is like the user binaries.
Yeah.
Obviously, this is all just in /user/bin now. So it's more of a legacy thing, but some distros like Slackware, for example, it'll have stuff in /bin.
Yeah, but nowadays they are just links for backwards compatibility for scripts and stuff like that.
Yeah, so that's generally like how a Linux operating system is actually created, and
that's how the That's how the rootfs is made, and really that is the definition of your distribution. Of course, when we say distribution, we more think about the desktop environment, the programs installed, but all of it is essentially defined by the distribution's root file system.
And when that's why we don't call them Linux operating systems. We call them Linux distributions because it's just a compilation of software. Now,
and for all of you, the operating system is the kernel. Kernel is the operating system because, as we explained before, the operating system is system software that manages computer hardware and software resources. Guess what? Kernel does that. And on top of that, problem is that people nowadays think only of users as humans, because some definition talk about users. I remember when I was back in academia, we had to actually define a user because of that. And a user can be basically anything that can interact with a computer. Anything from a remote server to a human who types on a keyboard like a caveman to a thing that plugs itself via USB cable and talks to the computer itself like another computer or a robot.
Yeah, that said, one of these days we will probably discuss like the differences between users, groups, and probably touch on file permissions after that. But that's another topic for another episode. When the newsfeed also sucks then.
Yeah, that's another type of user that I was talking about. This is like a user of a computer, the thing that sits in front of or like is touching the computer in some way or another. What is a user as in terms of operating system? It's essentially a definition of who or what you are and what permissions you have.
So let's talk about like the different distributions nowadays. So when we're looking at, obviously, if you look up like the Linux distro chart, you'll see a bunch of lines on this massive PNG image that's way too freaking big. That if the editor is smart, he's probably putting on the episode right now, right in front of us, and he's probably scrolling right down.
And you probably ain't seeing anything because the editor put the whole thing as a one big display, and you cannot.
It's cancer. So we're gonna talk from like the top level, as close to the top level as we can, right? So, and we're mostly gonna be talking about like the big name distros. So obviously, when it comes down to like distros, a lot of them are like downstream renditions or like repackaging of distros. So like Ubuntu is really just Debian under the hood with some differences. Or like Red Hat is actually downstream from Fedora. And if you argue enough, OpenSUSE could be like downstream Slackware, even though it's kind of a separate thing nowadays. Yeah. So let's talk. So to break down like how that works, let's talk about like the Fedora ecosystem, which is also called like the Red Hat ecosystem. So at the very top of that, you have Fedora Linux. This is like the top. This is like the upstream distro of choice. And from there, it branches off into CentOS, Stream, into Red Hat Linux. That's how that works. In the case of Debian, you have Debian, which stretches into Ubuntu. And then, of course, you have the other options of, Arch Linux, and then Arch Linux stretching into Manjaro. And then you got Gentoo, Slackware, and obviously there's OpenSUSE and its own family of distributions where, you have OpenSUSE, Leap, Tumbleweed, and the new one, Slow Roll. So that's what we've got those. Obviously, I'm known as like the Gentoo guy. I mess around with Gentoo, even though right now I'm using Fedora. Bigpod, you also use Fedora, but your Fedora is a little different from my Fedora because your Fedora is one of their atomic desktops. So that's gonna be one of those immutable things. We'll touch on that probably probably now's a good time to touch on what the heck an atomic distro is.
Well, essentially, an atomic distro is a distro that has certain parts of it locked down for editing and can be updated using principles of atomicity. So basically, what that means that parts update at the same time but separately. So if things go belly up, it just goes back to the old version and continues working. It's kind of the best thing ever.
So, in other words, it's an operating system where the user can change the things that the user's supposed to change and nothing else. And then the system just kind of sits back there and runs. And and the idea of it is that it's supposed to be as reliable as possible. And then there's another distro that's sort of in this realm that I don't necessarily call like immutable, even though some people will call them immutable distros or atomic distros.
You shouldn't call any distro immutable unless the whole file system is locked down and cannot be changed.
Then you have, but anyways, you have these other distros. These are what I call like the reproducible distros. Basically, it's a distro where it's effectively just a configuration file. So this is where Fedora,
the NixOS of the
this
world.
Is where you have NixOS, GNU Geeks, and you could probably argue like Fedora's CoreOS as well in this space.
It's still an atomic, same as atomic desktop. It uses the same principles.
It's the same principles, but you're also generating like an ignition file too. So you could run CoreOS like this too, if you really want to.
It's something of a mix of both.
So and then the idea behind those distros is that you just write one configuration file, and then the theory is that you should be able to share that configuration file with somebody else on a completely different system, potentially even different hardware entirely, and reproduce your same exact setup. That's the idea behind it. And I think like the best example of that is probably NixOS. Because NixOS has like its own can of worms to get into, and we're probably never going to like do a guide on like how to install NixOS because I'm not a programmer. Bigpod just doesn't like the language, and the documentation is actually kind of terrible. And you know what? If you want to learn how to install NixOS, there's YouTube videos for that, as well as a wonderful handbook that they provide.
And remember, we had a NixOS guy on our channel,
of course,
as a guest. Martin Wimpress Wimpy.
He'll be showing up one of these days. When
check out the episode. It should be somewhere in the back catalog.
Yes. That's right. We did do an episode when I was absent. That's why I don't remember this.
He doesn't remember he was absent.
But hey, one of these days, I will be able to talk to a NixOS user and actually have a debate with them. Because one of these days, I'm going to, and I want to do it on a recorded stream that I can link back to. Because some of the claims that they make are just wrong or inaccurate.
Like what?
Okay, so
give us
NixOS is stable. It depends on your definition of stable. Because, Debian is also stable. Do you mean... you want... So when you do a system update, and it goes wrong, you could select an option from your boot menu and roll back to a working system. I could do the same thing on OpenSUSE.
That's not a definition.
that's not stable. That's not stable. NixOS is immutable. You can change a configuration file. and stuff like that. So, anyways, I think we're probably exhausted on that topic because, while we were...
I still have something to say.
Distributions
don't matter.
Okay, I have a hot take for you, Bigpod.
They don't matter at all.
I have a hot take for you. You're right until the Linux distro decides that it does.
Not really. Remember when I said when I was describing how to make a Linux
Yes,
distro? It's all about the
that's
truth
true.
of us. You can take any file system, any set of files and put them on a system that all it has is all the necessity to boot, and you have your own distro or your own
Okay,
installation of
so
Linux. Really.
this,
So remember that. That's first of all. Second of all, and more importantly, a distribution in reality is just a set of packages which you can get yourself and get all the same things. There is nothing special about the distro that couldn't be done in any other configuration. The only distros that matter are, again, distros that have a different package manager or that use a different paradigm, like atomic, reproducible, and traditional. These are the three separate distros that matter: atomic distros, reproducible distro, and traditional distro. And each of them have a bunch of things underneath it that you probably shouldn't even go and wade in and just pick one and
yeah,
go with it.
you should just pick one distro, learn like all their tooling and learn how to fix the things that they need you to fix, because that's what I do. Unfortunately, I also run into the times where it's just like the distro decides that it wants to do its best to actually matter, which I know how to get around some of the stuff. Others, it's just way more annoying than it's worth the effort for. But for example, I use an Intel dedicated graphics card. Obviously, this requires that if I'm going to install like Debian Linux, I can get Debian to boot. However, I cannot get a graphical session if I install Debian stable out of the box.
Build your
Well,
own
yes,
kernel.
I could in fact build my own kernel. I could also enable the backport repo and pull in a newer kernel, but I also have to know how to do that. Which that's so that's where
And that's, in my opinion, it's not a distro problem. It's the problem of this one specific program called Package Manager. In this case, APT.
in this case, it could also be a problem of the Debian philosophy, because you got to remember, I installed Debian stable, which means that they're
Yes.
going to present the
Yes.
most stable distribution that they possibly can, because they put stable in the name. It's gonna have to work. So obviously, we're talking about packages that have been battle tested to high hell and back. So Linux 6.1, not 6.2, which is what I need.
So to close it off, what we just told you, Linux distribution is just a set of files that are thrown together and a package manager that manages it all. Nothing else,
Yes.
nothing more, or nothing less, nothing more. It's not that complex of magic that you need to have a distro. You could build one your own, probably in a couple of hours if you actually like try to be fast, especially if it's for yourself. Or you could just use a nice kits like you find with Universal Blue, or use something like the Bootstrap.
Yeah.
There
Now,
you go.
Bigpod, it's time
Everything you
to
need.
trigger at least one audience member, because we're going to be
Oh,
talking about
great.
Lennart Pottering. Now, for
Yay.
context of the record here, Lennart Pottering is the guy famous behind two very massive projects in the space of the Linux desktop. The first one being Pulse Audio, which, people just love Pulse Audio, and distro shipped entirely too soon, so people extra love Pulse Audio. The second one being Systemd, which is probably what's actually going to trigger like the one audience member, because somebody has to post an opinion on it. And if you're going to post an opinion, send it to this email address right here, contact@tugspace.com. You can also drop it in the YouTube comments, but send us the email, because I actually read that one. So Lennart Pottering decided he's had enough with distros. He's had enough. He needs to do the thing that Josh needs to do. He's talking about like how a distro should be made. Bigpod, we discovered this like right before the show. So if you wanted to like see some of our live takes on it while we were like reading through this, sign up on our Patreon, give us a couple dollars, get that pre-show, and give it a listen. Towards the end of it, of course, because it's a long pre-show because we just forgot we were recording a pre-show when we read this for. I think we had like a good 30-minute segment of just reading this article and discussing it. So hopefully it doesn't take that long. Take that long now while we're actually talking about that. But Lennart Pottering lays out a couple ground rules as to like how this distro is going to be made and generally how it's going to use. And it's all in System D because why wouldn't it be? So Bigpod.
Yeah.
How does Lennart say that a distro should be made?
So his design goals for a distro are: number 1, focused on image-based design rather than a package-based one. So essentially, just like something like Fedora Silverblue, the entire OS ships as a single unit.
Yeah, this is basically like how
so it is
Docker
atomic.
or Flatpak works. Like, it is a single thing that
Yes.
the developer writes, he confirms that it works on his end, he ships it and shares it with everybody.
Yeah. So basically, what he's saying that for robustness and security, it's essential for it to be a reproducible, immutable image, which describes most of the OS and large part of it. And again, if you go back to the previous part, the biggest part of the OS, like most of your distro, is /USR, which is what he's talking about, moving into this immutable image. Nothing more, just /USR.
All right, and just for clarification, he's talking about this from the concept of a desktop OS, not your servers. So
Yes.
there's going to be some very desktop-focused discussions here in these design goals, because if he's building an OS, it's going to be a desktop OS because, that's the one he actually uses, and that's what he actually says.
He also talks about the principle of cattle, not pet, which is essentially saying that your operating system, your computer, should be a cattle, just one machine, one cow among many, not a special pet you very much take care of and try to keep running. Which also means if your operating system breaks, you nuke and pave and you're done, because nothing else matters. Because it doesn't matter that you just deleted your operating system and put a new one on, which is really important for something like an image-based OS and like something that is immutable, reproducible, atomic. So, as his design goal number 2 is trust chain matters. Anything from when it starts with a bootloader and ends with the application, it should all be trusted via cryptographic
Yeah, so
validity.
grub the bootloader will then load the Linux kernel, which then loads your init system, which then loads your user space, which then loads your graphical session. That all needs...
All of it should be cryptographically checked.
Every step of that is validated before it's ran.
Yeah, and here comes the concept of secure boot and the whole feature of most of your computers, which some of you disable or hate. It's actually a really good feature. And here come encryption of all types.
Yeah, so full disk encryption, just partition based disk encryption. Pick one.
And this is actually very much reiterated on in the goal 3, which essentially says offline security matters as well, aka data should be reasonably safe at rest. For example, cryptographically inaccessible even when he leaves his laptop in a hotel room suspended. So his laptop should be encrypted as a rootfs in entirety.
Now, currently in like most Linux distros, if you install with like an encrypted disk on your system, you have to unlock it, which is that encryption passphrase that you type into your system when it boots up.
Yes.
Now, in the case of a laptop specifically, this is actually a security concern, because until you actually shut the system down, that all that data is actually not encrypted anymore.
Yeah.
Uh,
Yeah. But like you need to use it, so it needs to be
Yep.
decrypted. Like your entire root effect
it-
needs to be decrypted. You should probably layer additional encryptions on top of like home directory, which is where the features of systemd home D comes in. But in entirety, your system should be encrypted. So if you shut down your laptop or suspend it, even if somebody grabs your laptop or pulls out the hard drive, they cannot access the data. And that's why you need to use a password instead of relying on secure boot based attestation, which is what so many people rely on. And I think it's really, really stupid, because if somebody grabs my laptop and runs away with it, if it's shut down, if I'm using secure boot attestation, oh well, the system is might as well have didn't even have encryption.
Which he further touches on this for part 4, which is for like not just offline security but remote as well.
Yeah, it should be cryptographically measured so that remote attestation is supported. So for any software, it can be whether it can be checked on locally and remotely whether it is the right piece of software.
And of course, everything should be self-descriptive in step 5 here. The single source of truths that are closely attached to the object itself instead of stored externally. So, if there's a binary on the system, you should be able to tell what that binary does and how it's supposed to run.
Yes.
So he's saying that I don't necessarily think that he's saying like the source code should be there. But probably not a bad idea to put it on there, maybe.
But it should at least tell you it is what you think it is,
Yeah.
essentially, which is the cryptographic attestation comes in and
now,
stuff like that.
Step 6. I have an addendum I would like to add on to that. But what's step 6, Bigpod?
Everything should be self-updating, so they will know that software is never bug-free and thus require a continuous update cycle. Not only OS itself, but also an extension services and apps running on it.
So everything.
Here
Yeah.
I know what you're gonna say. I'm gonna
Oh, okay.
beat you to it. I'm gonna say this doesn't say automatically updated. Only says self-updated.
Yeah. So if you know what the GNU GPL license says, it says that you should be able to modify and share the software and so on. But that also gives you an implied right to just not update the software. So I
Yes.
support the idea of not.
But we're also talking about a license that says in itself that it's automatically
Well, that's why you just use
upgradable.
GPL v2.
Yes. The Linux version of it, not the
Yeah.
original version of it, because Linux kernel has modified it so it doesn't just automatically go to v3.
So now step 7 here, or goal 7.
Everything should be robust in respect to aborted OS operations, power loss, and so on. It should be robust toward hosted OS updates, regardless if download process fails, and require no user intervention to recover
Now,
the system.
This
and
is an
from
issue
those
that I
failures.
ran into one day way back in the day, and like my old, here I am just using Ubuntu LTS, moving from one LTS update to another. And I remember one time, I think it was like the Ubuntu 13. No, not 13, but 12.04 to the 14.04 upgrade, where during that update process, I actually lost power midway through, and turned out.
Yeah, that's a standard issue. Or do you control? Sometimes you might accidentally control C the wrong terminal
Or,
emulator.
your terminal might just crash, which I know doesn't happen often these
yeah,
days.
or your desktop environment
yeah,
might crash during an
So,
update. Maybe
yeah,
even
and
because of an update.
So basically, what he's saying here is that if that happens, you should still be able to get a system that boots.
Yes, and very likely you should get a system that was what it was before the update even occurred, because it's an image-based system. So you apply the image after it has successfully completed, not in the middle of it, which is what is the big problem of mine with traditional Linux package management and traditional Linux distros. Because if I go and update something and I do Control C in the middle of it, half of the update was done. Or even if I go and do an installation, half of the installation was done, which means, one, I have that craft left over. Two, I cannot delete it because package manager itself, I would have to do it manually, because package manager itself doesn't know about that package because it never committed the change to the package database.
Yeah, some package managers are smarter than others in that regard, but they're all, at the end of the day, they're all the same.
Yes, they all essentially splatter tarball onto a specific place on your file system and execute a bunch
if
of
all else
commands.
fails and you cannot get a rebootable system, you should have the nuclear option. That should be available to you. And that is where design goal 8 fits in.
There must always be a way to put the system back into a well-defined, guaranteed save state, aka factory reset. This includes all sensitive data from earlier uses becoming cryptographically inaccessible.
Yeah, so say like if your computer gets stolen and they can't encrypt get the disk encrypted or anything like that, and they choose a factory reset option because it used to be that you could do a factory reset and still be able to access like user files. He's saying here that those files shouldn't be accessible. But
yeah, and in the same vein, if you factory reset your own computer or you do it because you're giving it to somebody else, they shouldn't be able to just go and access your old files because they were on the drive. That shouldn't be cryptographically possible to happen.
And also, at some point, one of these days when you're using say this Android phone that I'm holding up here in my hand, every now and then I'll run into an issue on this phone where it's I will use that factory reset option because I've exhausted all other options, but I don't want to blow up the system. So
yeah, that's the whole point of the cattle not pet. You can just blow it away and start over, and
now,
you don't feel
there's
bad.
There's one distro that ships a boot option for this. That's Pop OS, where in the bootloader you go have the option to just reinstall Pop OS. That's basically a factory reset.
Yeah. Now, one that I actually really like is number 9. The OS should enforce clear separation between vendor resources, system resources, user resources, conceptually, and when it comes to cryptographical protection.
So,
this is what I've been talking about for a while, because in my opinion, you should split in many ways system resources and system programs from applications that are usable, that user installed. That's why I keep talking about dep packages, RPMs for system things, flatpaks for user things. That's one of the ways that should be split. But there are many other ways that such split should be made. So even location of where the packages are stored, like the actual files are placed.
Now everything here, if you live in a very high tech world and you have a better idea about these things and what we do or how we're describing it, you're thinking right now of a very specific system that only works in one specific scenario. But Linux got a goal about that on step 10. Things should be adaptive. The system should come up and make the best of whatever system it runs on. Adapt to the storage and the hardware. Moreover, the system should support execution on bare metal as well as a virtual environment. Or even in a container environment.
As well as
So
container environment.
The system should be just as fast on hardware as it is in a virtual machine or as it is in in a container. We'll get to the containers here in a minute.
And not just as fast, but should execute equally. So let's say I do an action. That action should be exactly the same between a container, VM, and bare metal. Something these days you cannot actually 100% guarantee with many of these desktop operating systems. Like, a lot of people keep saying you shouldn't live in a VM because things will be different. Why? Why should things be different? They shouldn't be. It's an emulation. It's really a computer within a computer. It should be exactly the same. And if you as a programmer cannot actually do that, then you probably failed your program. Sorry. And a big part of this comes to OS itself.
Yep. And then here's step 11. Making it like actually usable. Things should not require explicit installation. Every image should be a live image. For installation, it should just be sufficient to just use the dd command to spam the image onto a disk. Thus, a strong focus on instantiate
on first boot instead of instantiate on before first boot. Essentially, what he's trying to say, it shouldn't be one specific way to splatter the system onto the drive. There should be many ways to splatter it, and all of them should be equally valid.
And of course, we don't want too much cruft in the system. Things should be reasonably minimal.
In the base system.
It should be like the image just starts its life, should be quick to download, not really run too heavy, and it should be just enough system that the user can reasonably use it, as well as add their own stuff on top of. Because at the end of the day, you want to have a system that just works. So in this case, think about it this way: like, he ships a live GNOME environment with just GNOME software, and maybe a terminal.
Yeah, and a terminal. Or think of it this way: enough software that you can actually get up and running. So a notepad of some sort, a basic stuff like that. Think of it like Windows. Why doesn't Windows ship with Office? Why doesn't Windows ship with X? Why? It has a browser, it has notepad, it has a calculator, so basic tools so that a normal person get up and running without need to have anything extra. But when you need something specific, you can get your computer to have it. And that's what most Linux systems should strive to, not have everything under the sun on it, just so it has.
There are too many distros I install where the very first thing that I do is start removing stuff. I shouldn't have to do that.
Same. Why does distro need a LibreOffice on it, or a mail client?
I mean, I'm not going to argue that it shouldn't be there, but the year is 2025. Most people that are installing Linux also have an internet connection. It doesn't have to be there.
Yeah.
The user can always just install it.
Yeah.
So that is design goal 12. So design goal 13, system identity, local cryptographic keys, and so on should be generated locally, not be pre-provisioned. As in, there shouldn't be one key that the developer makes, and then that's the key that everybody uses. No, that should not be a thing. Well,
There's some reasons for having that. For example, signing, let's say, a driver, signing, let's say, like an image for transport.
Yeah.
But everything then, after everything is loaded onto your system, it should be separately signed locally with a key that only exists on that machine, and is never transported with the image, with a piece of software, with anything of this, as much as that is possible.
And then design goal 14 is what makes this system no longer an immutable system, but more similar to an atomic distro or a a reproducible distro. So things should be reasonably democratic and hackable. As in, I should be able to change things on the operating system. It should be pretty easy to fork the OS, modify the OS, and still get a reasonable cryptographic protection. Modifying your OS should not necessarily imply that your warranty is voided, and you lose all good properties of the OS, if you so will. So basically, what he's saying is, I should be able to change things in my /var. I should be able to.
You must actually for
Yeah,
Linux to
you
operate
must.
properly. Technically, you don't have to keep that over on the boot, but it's highly recommended because things need to be generated again,
Yeah.
and that takes time and resources for no reason, like I/O, like CPU.
Yeah.
Why?
That said, if I just randomly RM something in /user bin, that shouldn't be like my warranty is voided. That's hey, that's a thing that he's saying that I should be able to do, but I shouldn't have like my operating system blow up because I did it.
Yeah.
And then of course, design goal 15. Things should be reasonably modular. So the privileged part of the core OS must be extendable, including the individual system. It's not sufficient to support extensibility just through high-level UI applications. So what he's saying here is that you shouldn't have like Flatpak as the only option. You should be able to, download a binary, put into /opt. You should be able to do things like that. That's basically what he's saying. The system should be modular enough to allow you to do that. Because, at that point, you're not really working in the high level. You're working in a little bit low level, at least in comparison to, like, the user interface. And then design goal 16, things should be reasonably uniform. Ideally, the same formats and cryptographic properties are used for all the components of the system, regardless for the host OS itself or the payloads it receives and runs. So everything should have like the same key.
Use same
Have
hash,
the same hash
and so
algorithm.
on.
That way, like when these things are getting cryptographically verified, it's a little bit easier. Where it's just like, say, like if I launch Firefox on this system, that should have like a key that's processed the same way as the same key that would be used to launch, like, say, my file explorer or my file manager. I mean,
Yeah.
sorry.
And the last design goal, 17, even taking all these goals into consideration, it should still be close to a traditional Linux distro and take advantage of what they are really good at: integration and security updates.
As in, it should be able to make full advantage of the open source model. It should be able to have that tight integration that you can have with open source projects, and be able to get that super fast security update cycle that oftentimes we get way faster than what we would get if we were using the proprietary options. Where say if there's like a critical vulnerability in like our printer stack, it's theoretically possible that our printer stack is going to get fixed long before it does on like Microsoft Windows.
Yeah, and more importantly, I think what he means here is that the applications, or at least system components, get shipped by a package manager, not from a bespoke system, like copy pasting files onto another file.
So these,
what will at the end of the day represent to the fast.
So now that we basically spent 20 minutes talking about like his design goals, it's time to actually talk about how he would make the system. And he uses the word hermetic in this. Now, hermetic is not a word that we Americans typically use, but it's basically an adjective. It means that it's completely sealed, especially against like escape or the entry of error or like interference or influence. Basically, this should be the thing that shouldn't change, in theory. So, and he says hermetic /user.
So what does that mean? That means essentially that it is immutable. That all use OS resources, code, data files should be hermetic, should be immutable in /usr, which means the /usr tree should carry everything needed to set up the minimal set of directories and files outside of /usr to make system work.
Yeah, so this is where...
that means that /usr can be mounted read-only, and everything else should be then carried separately.
Ideally, when, say, like, I'm making an image for this operating system, I'm putting everything in /user, and then it's on the users to modify everything that's out of /user. If, they so choose so. But I should have a in /user, I should have at least a predefined /etsy and /var and /home for, like, the home skeleton structures, so, like, your .config folders, for in /etsy, that's like where all of your system configuration is, so how that system would be set up. And something that it says here is that there's a couple distros that are basically already set up similar to this, like Fedora.
Yeah. Most of Fedora already runs out of /usr, primarily because of the thing called Fedora Silverblue, the Fedora Atomic Desktops. Because that's how Fedora Atomic Desktops really work, is by USR being non-changeable, immutable, and so on.
And then he says that some of the directory trees outside of /user should just be automatically generated as needed if, say, like, they're missing. So, like, your Etsy password or your Etsy group files, which are the things that, manage your passwords as well as your system groups.
Yeah.
And he'll touch on that here a little bit later for, like, say, like, the partition table. Because, he's not using an fstab file with this. He's getting a little bit complicated there. But he talks about /user a little bit more. So it's a comprehensively defined. Everything in the system is defined within /user. So if you compare, so when the system boots, it's going to compare to, like, what's in the /user versus, like, what's everywhere else. And if anything's missing, it'll pull it out of /user. And of course that's going to open a few doors. Like, say, he can then apply the DM verify out of the DM crypt tools. Yeah.
DM Verity.
DM Verity, to basically, like, guarantee the structural integrity of, like, the system. And then we implement the updates to the OS easily by doing this, by just having, like, an A and B /user. So, like, an updated /user and a current known working /user. Basically like the Android model, where it's like you got two different root file systems, one that works and then one that's pending to work. And of course, the factory reset option should also just be in /user as well. So then he talks about the partition table, because obviously, if we're not using /etsy to define everything, we're putting everything in /user, and we're dynamically generating these files, do we really need a /fs tab?
Not really. If everything is well defined, it should the dynamic partition specification, discover partition specification, which is also part of systemd, should be enough to figure out everything that is to figure out about the file system, and should mount it in the right places, which means no fs tab, and it should allow for basically via any way to mount the root file system, including using systemd and spawn.
Yeah, so basically what it does is it looks at, like, the partition table of your disk, and it says that, hey, this looks like a root file system, this looks like a home file system, so, and this looks like a swap partition.
Yeah.
It'll talk about swap partitions in a minute. And it'll just dynamically generate an FS tab for those appropriate files. Now, it's a little bit smart. It does this a little bit smart here because, it checks to see if, like, that's actually a root file system, or if, it's mistaking a root file system for a home directory. I ran into that before, too, where I accidentally mounted /home as root. That was an interesting experience. So, that so it and there's just no sense to just generate the FS tab if you've already got a system that does that. And of course, he does talk about like how the system is set up. First of all, it's a UEFI system because why would it not be?
Yeah.
Obviously, it's mutable, verity protected signed system with a user with the /user tree in version A as well as B. And we're assuming that this is a writable encrypted root file system. Obviously, now this matters because we're going to be talking about this as we go. So, anyways, now that they know how to organize a partition table, let's talk about booting.
So it is supposed to use a unified kernel, which means both the kernel and the init ramfs, which is initial boot disk that you first gets injected, which then boots the kernel, should be essentially fused together into a single binary, which allows them to be cryptographically signed using a single cryptographic hash, and it should allow easier updating, as you all need to do is drop in one file instead of multiple files.
Yeah. So.
And each of these unified kernel should be all attached to a single version of /usr3, and should be updated along the /usr3.
Yep. And of course, he's the guy that made systemd, for example. So he's talking about like this in the context of systemd boot doing this. He says that systemd boot, it's a simple loader, and I agree, it's a simple loader. And it does, of course, implement the bootloader specification of UEFI with secure boot and, multiple root file systems. That means that it requires no real explicit configuration or anything. And now he's wondering how to configure the root file system to boot from with such a unified kernel that contains the kernel command line and is signed as a whole and thus immutable. The idea is to use the user hash equals kernel command line option. This is implemented generally by like the systemd verity setup generator as well as the systemd fs tab generator, which does two things. First of all, it will search and set up a dm verity volume in the /user file system, and then it'll mount it, and then it'll take the root hash of the dm verity Merkle tree as the parameter. This hash is then used to find the user partition in the GPT partition table. And it's going to assume the partition UIDs are derived from that. And generally that's how it's basically spawning.
Yeah, let's keep this into a more digestible section, because you already mentioned things like Merkle trees, and I really do not want to explain.
I don't want to look that
stuff,
up.
So let's just go further and talk about one of the things we already mentioned. So factory reset should be easy to achieve and ensure a good state. For example, ensure that if there are any new exploits that were loaded, that should just go away. And systemd repart is the tool that he proposes to use for this, as it already has mechanisms to this. And the actual factory reset should be requested by one of two means, but one of them isn't actually good because UEFI secure boot is a thing, so it doesn't really work. The other one is via an EFI variable, which is honored immediately following boot, so it does the factory reset right after the boot. My guess is init ramfs boots, and once the complete system is back, so it does the factory reset, only ESP, the UEFI system partition, and /USR file system will exist, but the whole of rootfs would be gone, and it can do a first boot and just generate a new rootfs for the whole, so home directory and all that.
Yeah, so generally when your system boots, it'll obviously just pick the newer kernel because, it's always nice to run the latest and greatest, which includes the initial RAM disk and the secure reference. Then, because, this works and it's great, but a slash user alone won't make us happy. We also need the root file system. That's where the system would actually be writable. And then /etc and /var is generated.
Yeah. Now, Josh, take us into the world of modularity of this kind of an operating
so
system.
the general idea here is that when the system boots up for the first time, if it doesn't see the /etc and /var, it should just generate whatever the predefinition /user is. So it should give you a working system with those. It's going to spawn like your SSH keys, as well as a couple hashes that the system needs to remain encrypted. Obviously, they're using Linux 2 encryption, which is, pretty much the standard at this point. And it's saying that if that stuff isn't there, it's just going to make it. Then later, I as a user should be able to go into /etc and be able to change the configuration file in there. And it's going to say that the configuration file is there, and it's just going to be like, okay, that's fine. That file is writable. It's supposed to be there. It still has like this cryptographic key attached to it. So I'm not going to change it or anything. I'm just going to boot and, just use it. Now, Lennart does say that the system does need to be encrypted. And he's going to bind the Linux 2 encryption to the TPM2 chip that's probably on your system if it's a newer system. Now, there are some systems that still don't support TPM2. But at the same time, most of them do support TPM2 to some context. But of course, he doesn't want to get too lost in the details of TPM2 devices on that there, because there's enough for like a novel. But what he wants to do is just use TPM2 bound key for unlocking root file system get us. We can encrypt the root file system with it, and you can only read or make changes to the root file system if you possess the proper chip. That's really what the end goal of it is. So somebody shouldn't just be able to swap the hard drive out and have it into like another system and expect your hard drive to be able to boot, even if they have the password.
Yeah.
That's the idea of the TPM chip, because that's the Trusted Platform Module. That's what TPM stands for.
Yeah.
And he spends like the next 2.5 paragraphs on this.
Well, I have a bit spaced out, so I don't know what's next. So I'm just gonna pick something that I think you probably haven't talked about. Running the OS itself in a container.
Of course. Now this is the neat part about it, because he hasn't quite figured out how he exactly wants to do that yet, but this is how he would want to run it.
Basically, one of the stated goals, to reiterate, is that OS to be adaptive enough to run in a container environment. He specifically wants to run in systemd and spawn, and I could go on and on about why I don't like systemd and spawn, but at the end of the day, just another offering in the world of LXC, LXD, and stuff like that. So it's just another one of those, with one big difference. In my opinion, it's just a souped up version of chroot, because you point it at a rootfs and it will work. Big problem with that is that there is no way to really you need to download a file and then unpack it and all that to get a rootfs for it to work with an endspawn. There are some tools nowadays that have servers and stuff like that, but in long term it's literally just a rootfs. You download, put on a directory, and then point and spawn at it. which
Now,
is
the
why I
main
don't
reason
like
why
it.
he's talking about like running everything in a container is for more modularity. Because if you're running everything in a container,
Yeah.
you can boot up a secondary container with a more immutable system. So like a more normal version of Linux. So like, your Ubuntu
Yeah.
as a just a second actively
Uh,
running operating system on your computer, if you want to.
that has been tried many times already. Anybody heard of this thing called DistroBox?
Yeah, but what he's proposing here is a more native system from like the more core operating system level. So not necessarily like something that's running in like your user space it's all at the end of the day ran in user space, but like your user system, but more like the operating system.
So basically, where the problem lies is he needs to figure out the validation logic. So the part to cryptographically validate the whole system, because unlike with the normal boot sequence of whether it be a VM or a bare metal, there is no boot up sequence since the container manager, in this case nspawn, will automatically call PID1, aka the init system, to and start it inside essentially a
Yeah, because
separate namespace.
it doesn't make sense to run more than one kernel at a time.
Yeah, it would actually work. In this case, we need to actually virtualize a new system, because essentially containers use the one kernel that is already there, and just split the features apart using Linux namespaces, like networking, like processes, like file
Yeah,
systems, and
he
so
says
on.
that System Enspawn has some really nice properties when it comes to integrating with this here. For example, it can just use bind user permits to hold the user record and their directory in a container as a simple one-stop operation. So, if you're going into one of these other containers, like say, you have your host system and then you're using an app. Well, we'll use like the DistroBox example here. So if you use DistroBox to enter into a say an Arch Linux container on your Fedora system, you should be able to see the same home directory as what's on your Fedora system when you're doing this. So that way you only have a single user with a single host. And then of course he's talking about here is just like, hey, there's also an option that we should also have on our immutable distro called, and he calls this developer mode, which is basically just like unlocking the lock on that /user folder. He says that there should be a system that allows you to adjust that. Which, hey, I support that. Because, at the end of the day, it's free and open source software. Let me do whatever I want with it. And of course, he proposes two different options. For example, how to do this. And I'm blanking. Yeah.
He's
I'm
blanking, everybody, if you didn't hear. So, first version of it would be allow users to additively extend, override the OS via local developer system extensions. With this scheme, the underlying cryptographic validation would remain intact, but in the form of development model is, if this form of development model is specifically and explicitly enabled, the developer could add in more resources from local storage that are not tied to the OS builder's chain of trust, but a local one, simply backed by encrypted storage of some form. The second approach is to make it easy to extend, or in fact replace the set of trusted validation keys with local ones that are under control of the user, in order to make it easy to operate with kernel, OS extensions, portable service, or container images signed by the local developer without involvement of the OS builder. This is relatively easy to do for components down the trust chain, but there is no such thing currently enabled. So there is no such thing as developer mode yet.
But he does think that it should
And
be added.
he thinks it should be added soon.
And of course, we should also have democratized code signing. Because, you know, if I make a thing and I have it on my system, I want my system to be able to approve the thing that I made, even if with, you know, the key that I gave it. That's generally what he's saying here. So, and that's where UEFI secure boot code signing kind of falls into a bit big of an issue. And overall, it's pretty sad because, you know, secure boot is working as intended by, you know, blocking some applications from actually running. Sometimes.
And I think we are probably losing you at this point, so we're gonna jump a couple of things and really quickly talk about updating. So, in his rough idea of how, since we have a rough idea of how system is organized, we can focus on updates. And updates should happen using sysupdate, another one of systemd tools, and it's a very simple AB image updater. So we have two partitions. One of them is A partition, one of them is B partition. When A partition is in use, update B partition. And you literally go and pull the entirety of /user into that unused partition and place it there.
Yeah.
And another important part is boot counting and assessment. Essentially, what he wants to do is for you to, if let's say you boot your system and it doesn't boot, and restarts and boots again and doesn't boot, and does that 3-4 times, system just goes, nope, I'm booting to the older version.
Yeah. So the end expected here is you hit the power button on your computer, you should be able to get something out of your computer eventually.
Yes. Sooner or later, after a couple of cycles, you will get a desktop. That's kind of the point that should be more pushed by, not just by this, by basically any distro.
Yeah, that said, obviously, by default, the system should just pick whatever's newest.
Yeah, but that's not always possible. Again, because of bugs.
And then now is when he gets talking about the home directory. Now, the home directory in this context is something that we can technically do right now, but no distro is actually doing it yet. And that's using systemd homed, which means that the user home directories are just able to be migrated between devices. That's really what homed was actually created for, was a way to make the home directory portable. So you could theoretically take the home directory from one system and seamlessly move it to another. That's what it's talking about. And it's wanting to manage it through systemd system. That way, it can work with the encryption during system suspend, which I'm not real knowledgeable in how systemd's home implementation works, and I'm probably gonna try messing around with it one of these days. But I know, traditionally, Luke's passphrase is kept in memory. Bad choice for security, obviously. He doesn't really have a solution for this right now, but it does look like he's still working on trying to figure that bit out.
And at this point, I think we should probably go towards the end of the episode, since we're in for about more than an hour and a half. So I'm gonna quickly go through different jumps. Like, for example, he recommends BTRFS as the only real option in his opinion. He talks again about how systems should be instantiated on first boot instead of on installation. so installation should just splatter things on the drive. He talks about things like how live system, installer system, and install system shouldn't be three separate environments, should be one single environment, and how to build images based on this model using MKOSI, another thing made by systemd team. And then he goes into his final words, which I think is the thing we should be right now talking about. So his goals are get distributions to move to closer to this kind of a model where distributions make their OS hermetic in /USR. Find overlaps with other projects to revisit how the distributions are put together, and make people interested in building actual real-world images based on general-purpose distributions adhering to the model he described above. And he wants to name this for like the actual OS if it has GNOME book based on corollary of Chromebook.
This is generally how Chrome OS itself actually works. Now, of course, if you want to try this, I have the GitHub page for Particle OS linked in the show notes. I just pulled that up and added them to the show notes while we were talking because I just thought I should probably have that in there. And this will set up a system generally like how he describes, and it can either be based off of Arch Linux or Fedora, and you'll have KDE or GNOME. It doesn't really support like anything else right now because he's learning our pottering. He doesn't use Sway. So,
and there is a lot more information on this blog post. He writes extensive blog posts. Blog post is also linked down in the description or in the show notes somewhere, wherever they are around you. And
of course, you've probably got some questions.
Has an FAQ.
You've probably got some questions. There's an FAQ. We're not going to touch on that right now. So if you want,
there is also how can you help section, and links to additional documentation of used components and concepts.
Yeah. So obviously, give this a read for yourself. We were just kind of just like summarizing it for you. Ultimately, I think that this is a good idea for like distros to move this direction. Probably not like implement everything, but there's a lot of good ideas here.
But there are some things that are quite good as an idea.
Yeah. So, anyways, if you would like to talk about us or even rage about systemd, send us an email. contact@tuxbase.com. We have a community we have a Discord community that people do actively show up and talk in every now and then. It's not just us talking to each other all the time. Every now and then we see somebody in there. If you'd like to support the efforts of this show, go to patreon.com/NoTuxAllowed. Now, give us a couple $. Listen to that pre-show, especially this week, where Bigpod and I discover this here based off of a YouTube recommendation. That I just open up the YouTube page and I'm like, whoa, what is this? And I run into this. And of course, if you want to shout at us directly, we've got these links right here. These are our Fediverse IDs. You can talk to us there through Mastodon or Threads. And one of these days we'll probably talk a little bit more about Mastodon because I think that the Fediverse is a really cool concept. We've also got our own YouTube channels, and you can find links for all of that stuff at tuxbase.com. In the meantime, guys, that is No Tux Allowed on a very long episode. I am hungry, and my belly is telling me that it wants food. And Bigpod, you probably need to go to bed. So I will say goodbye and see you next week.
Goodbye.